In this video, we will discuss the role of water in sedimentary rock formation. Sedimentary rock and the processes that create it, which include weathering, erosion, and lithification, are an integral part of understanding Earth science. This is because the majority of the Earth's surface is made up of sedimentary rocks and their common predecessor, sediments. Even though sedimentary rocks can form in dramatically different ways, their origin and creation have one thing in common: water. The water molecule consists of two hydrogen atoms covalently bonded to one oxygen atom arranged in a specific and important geometry. The two hydrogen atoms are separated by an angle of about 105 degrees, and both are located to one side of the oxygen atom. This atomic arrangement, with the positively charged hydrogens on one side and negatively charged oxygen on the other side, gives the water molecule an uneven magnetic charge. This property is called polarity. Resembling a battery or a magnet, the molecule's positive-negative architecture leads to a whole suite of properties. Polarity allows water molecules to stick to other substances. This is called adhesion. Water is also attracted to itself, a property called cohesion, which leads to water's most common form in the air, a droplet. Cohesion is responsible for creating surface tension, which various insects use to walk on water by distributing their weight across the surface. The fact that water is attracted to itself leads to another important property, one that is extremely rare in the natural world. The liquid form is denser than the solid form. The polarity of water creates a special type of weak bonding called hydrogen bonds. Hydrogen bonds allow the molecules in liquid water to sit close together. Water is densest at 4 degrees Celsius and is less dense above and below that temperature. As water solidifies into ice, the molecules must move apart in order to fit into the crystal lattice, causing water to expand and become less dense as it freezes. Because of this, ice floats and water sinks, which keeps the oceans liquid and prevents them from freezing solid from the bottom up. This unique property of water keeps Earth, the water planet, habitable. Even more critical for supporting life, water remains liquid over a very large range of temperatures, which is also a result of cohesion. Hydrogen bonding allows liquid water to absorb high amounts of energy before turning into vapor or gas. The wide range across which water remains a liquid between 0 degrees Celsius and 100 degrees Celsius is rarely exhibited in other substances. Without this high boiling point, liquid water as we know it would be constricted to narrow temperature zones on Earth, instead of being found from pole to pole. Water is a universal solvent, meaning it dissolves more substances than any other commonly found, naturally occurring liquid. The water molecules use polarity and hydrogen bonds to pry ions away from the crystal lattice. Water is such a powerful solvent, it can dissolve even the strongest rocks and minerals given enough time. In summation, water plays a role in the formation of most sedimentary rocks. Water is the main agent in the production of sediments and sedimentary rock. As the universal solvent, it is involved in creating the minerals in chemical sedimentary rock. Ice expansion makes water an especially unique substance integral to the breakdown of bedrock. Once broken free of the bedrock, water physically tumbles rocks, breaking them into smaller pieces. Water transports sediments and deposits them in layers. These layers are chemically cemented together with the minerals dissolved in water, forming clastic sedimentary rock. So, in conclusion, water is the fundamental agent in producing clastic and chemical sedimentary rock.